In this video, we will demonstrate how to set up a typical project to control the Wrappa interfaces. It is assumed that you have already configured your Wrapit hub and at least one Wrappa. If not, please refer to the Getting Started video, which will guide you on how to set up your Wrappa system. So now let's jump right in. First, on your PC, open up a new tab in your web browser and enter the following in the URL search bar: wrapit-hub.local:1880. You are now in the Flow Design environment where you will be developing your project. Now open up a new tab on your browser and in the URL enter wrapit-hub.local:1880/UI. In the dashboard, expand the Wrapit Hub Information tab and click on the blue button to refresh the status. If your IP address is presented, then you know that you are connected to your local Wi-Fi router. Now let's check if the installed Wrappa has been discovered. Expand the Connected Wrappa Information tab and click on the blue button to refresh the status. You should be able to see your Wrappa, the reported Wi-Fi signal strength and the IP address that it's been issued by your router. Now click on the first browser tab. We are now in the design environment, and on the left of the screen we can observe the various Wrapit nodes at the top and additional functional and dashboard nodes further down. To develop a flow, you simply drag and drop the required nodes onto the canvas, configure them and interconnect them logically. Let's start with a simple example where I'll also try and explain some of the features of the Node Red design environment. Let's drag a digital output node to the canvas. We now drag an inject node to the canvas and we connect the output of the inject node to the input of the Wrappa digital out node. Now let's take a closer look at the digital out node. Double-click on the node and in the third field, Wrappa name, enter the unique name that you gave to your Wrappa. The default values in the first two fields can be left as they are. In the next field, give this node a meaningful name. In the next field, Wrappa terminal refers to the electrical screw terminal on the Wrappa, select D6. To finish, click the red Done button. Now select the information icon that looks like a notepad at the top right. We now observe all the necessary information about this node, how to configure it and what messages are exchanged with it. We have already completed the first part, and as we scroll down we note the input messages that this node will respond to. Messages have a topic and a payload, which is the content. Here we see that the topic is set pin state, and the payload can be either high, low, or toggle. That's all we need to know. Now let's double-click on the gray inject node and set the appropriate values. Let's set the message payload to toggle and the topic to set pin state, as advised in the description. Now, click the red deploy button at the top right of the screen. Let's now check to see if all is working. Click on the gray button on the left of the inject node. We now observe that the LED associated with the D6 terminal on the Wrappa lights up. You should also hear the relay engage. Successive presses of the button will toggle the state of D6 and the relay from high to low. The relay can be disengaged if not required, by removing the leftmost jumper pin on the Wrappa. Sometimes, you may get your logic wrong and you will need to examine what messages are being passed between the various nodes. We can examine the messages at various points by inserting a debug node. Let's drag a few debug nodes and connect it to the output of each node. Click on the red deploy button, which you must always do after any change, and then select the debug messages icon, situated to the right of the help icon. When we click on the inject node, we can see that the first node sends out the toggle message and the digital output node issues either a high or low message, which gets sent to the Wrappa. Now let's see how we can turn this into a more functional and impressive result using dashboard control. We now drag onto the canvas a button node, a text node, an LED node, a chart node, and we interconnect them as follows. And a change node, We first configure the button node. Double-click the node and at the very top under Group, select the Digital Demo tab and Group. This is where this flow will be displayed on the dashboard. We write a meaningful label description, set the payload field to toggle, and set the topic to set pin state. We click Done and go to the LED node. Likewise, select the Digital Demo tab and Group. Here we choose the payload to be a string and set the value to low. We can choose any LED color we want. We repeat the process for the alternate state and color of the LED and choose high for the green. Press Done to complete the edit. Now double-click on the text node, select the Digital Demo tab and Group, and in the label field, enter the text, level is. In the layout you can select any format you like, then click Done. Now, we know that the output of the digital out node is text string with values high or low, but a chart node requires a numerical value. So, we will use a change node to change the text string from low to a numerical value of 0 and the high to 1. So, select Change to search for high and replace with 1. We add a second condition and similarly we select Change, search for low and replace with 0. Click Done to complete. Now double-click on the chart node. Select the Digital Demo Dashboard tab and the Group. Then for X-axis select the display interval for 1 minute. On the Y-axis field, enter a minimum of 0 and a maximum of 1. You can select any color that you want for the chart, then press Done. We are now finished with the design phase, so we can click the red Deploy button and look at our result in the dashboard. Go to the Dashboard tab in the browser and click on the hamburger icon at the top left of the screen and click our Digital Demo tab. We now observe that as we click the blue button the Wrappa responds accordingly and the virtual LED changes color, the message shows either high or low and the results are plotted on the chart over time. You also have the flexibility to change the layout of the items displayed in your dashboard. To do this, go back to the Flow Design tab and on the panel on the right expand the rightmost icon at the top and select Dashboard. Select and expand the Digital Demo Dashboard, which will show the order of all the elements in the dashboard. So, for example, should you wish to change the position of the text output, shown as level is, hover over it and drag the hamburger icon to your preferred location and click Deploy on completion. Going back to the dashboard, we observe that the output position from this node has now changed. Wrapit-Solutions provides numerous working examples to help you get started with minimal delay. Some of these examples include flows for specific I2C products like BME280 weather sensors and LCD displays. These normally require significant software development to interface with and which users can benefit from by simply importing any of the working examples. Let's demonstrate and import a working example. Click on the hamburger icon at the top right of the screen and select Import. Choose Examples and then Wrapit nodes and select Analog In and Analog Out nodes. Click the Import button and when prompted click Import Copy. You should be able to view the various nodes and connections with the imported flow. The only modification required is to edit the two nodes labeled Wrapit Analog In and Wrapit Analog Out and update them with your unique Wrappa name. Double-click on each of these nodes, leaving everything as it is, except for the third field, labeled Wrappa Name. Here you enter the unique name that you gave to your Wrappa. We note that the slider node value is sent to terminal D1 as a variable analog output value. You need to first wire a connection between terminal D1 to the analog input terminal A1. Now, click Deploy and go to the Dashboard tab of your browser. Click on the hamburger icon on the left. Click on Analog In and Analog Out nodes. As can be observed, moving the slider at the top changes the analog out on terminal D1, which is detected by input A1 and displayed on the multicolored gauge. Thresholds are also implemented in the flow design, which illuminate two LEDs when the threshold values are exceeded. That concludes our video tutorial VT1. Please refer to our other videos on this channel where we examine other features and capabilities that you may find helpful in proceeding with your project.